Remember, each CRUD operation has its own SQL keyword.
We already know the keyword for reading from a database, select. The keyword to create a row is insert. Let's take a look at a general use case to insert data into a table. You start off with the keyword insert into table name. This tells the database you want to insert some data into a particular table. Then you include the keyword values followed by the values we want to insert into the table. The values are surrounded in parentheses. The order of these values are important. The values have to be inserted in the same order the schema describes the columns. Let's take a look at our library database and insert some new books into our books table. This is what the books table looks like now. We have an ID, title, author, genre, and first published columns. The last book ID is 15. Our new book should have the ID of 16. Let's write the SQL statement to insert George Orwell's 1984. First, it's insert into books, followed by values 16, the string 1984 as the title, George Orwell as the author, fiction as the genre, and first published is an integer of 1949. Let's run that. And as you can see, it's been inserted into the books table in the correct columns. Selecting all records, looking at the last ID, and then incrementing it by 1 yourself as you enter new rows into a database seems like a lot of work. Also, other database users may be entering their own rows. Your generated ID and their generated ID may clash. Remember, IDs are supposed to be unique, and they're used as a reference for a particular row in the table. SQL databases have automated this tedious dance, and conflicts can be avoided with a feature called auto-increment. Auto-increment generates the latest ID for you so you don't have to. Most database tables with the ID column will have the auto-increment feature switched on. People who designed the database schema would have most likely switched it on. Let's insert another book, Dune. Instead of having an integer, we enter the value, or rather the absence of a value, null. When the row is inserted, because the ID column has been designated as an auto-incremented column, the database will give the new entry the correct ID, which is 17. Sometimes, if the schema allows, you can insert null values into columns when you don't know the information or you want to fill it in later. For example, in our loans table, we have missing values in the returned on column. This is because they haven't been returned yet. If we wanted to enter a new entry into the loans table where we didn't want the value to be entered into the returned on column, we could just use the value of null. Now, it's not very clear what all these values are. Luckily, SQL has an alternative way to make this clearer. Just after the table name, we can include another set of parentheses with the column names in. Then followed by the keyword values. And then all the values you want. You're also not restricted by ordering the columns in this order. As long as you order the values in the same order as you order your columns, they will get inserted correctly. For example, I could move the ID to the second to last column in the columns entry, if I move the ID to the second to last and its value to the second to last, it would have the same result as if they were written in the order they were in the schema. You can change this into any combination you'd like, as long as the order of the values matches the column order in your statement. Even with the book ID moved to the third column and value positions, this same result will happen. The row will be created with the correct values in each column. Only the ID column will get auto-incremented, not the returned on. The value in this case will be empty. Finally, because the ID and the returned on are null, meaning that they are absent, we don't have to specify them in our columns or values. The database will automatically know that they should be null because you didn't specify them. When we run the statement, we see the final sixth row entered with the auto-incremented ID and the returned on as null. We can write the general case of these insert statements like this. The insert into keyword combo, followed by the table name, all the column names that you want to enter values in, surrounded in parentheses, then the keyword values, followed by a value-filled pair of parentheses. Something you should be aware of is, while some columns allow for null values, database designers require certain columns must have a value present. For example, if we wanted to delete the book ID and the value in our insert query, and we tried to create a new entry, we would get an error. Error. Not null constraint failed. Loans.bookid. It doesn't make sense that we should be able to create a loan without an associated book. The schema has been designed with that in mind. In fact, the ID, book_ID, patron_ID, loaned on, and returned by cannot have null values. Only the returned on can be null. This makes sense, since it's going to be returned at a future time. People can get extensions and update the returned by, but it can't be null.